Introduction. Dual piston pumps is more efficient way to provide a constant and almost pulse-free flow. Both pump chambers driven by the same motor through a common eccentric cam. This common drive allows one piston to pump while other is refilling. As a result, the two flow profiles overlap each other significantly, reducing the pulsation downstream of the pump. Since the acceleration or deceleration profile is somewhat nonlinear, the more efficient types of these pumps use eccentricity shaped cams to obtain the best overlapping of the pressure curves and to obtain smooth flow. This is the schematic diagram of dual piston pump.
Of pump. Piston pump comprise of type of volumetric unit with this space used to push liquid from static working chamber. The basic component of piston pump are the working chamber and a displacer. The displacer is an operating element that displays substance from the unit working chamber. For volumetric pumping equipment, the working chamber is the enclosed space alternately connected with the pumping plant inlet and outlet. Connecting rod, also called a cone rod. It is a part of a piston engine which connects to the piston to the crankshaft. Together with the crank, the connecting rods convert the reciprocating motion of the piston into the rotation of the crankshaft to transfer combustion pressure to the crank pin. Suction valve is a non-return valve, which means only one directional flow is possible in this type of valve. This is space between suction pipe inlet and cylinder. During suction of liquid, it is open, and during discharge, it is closed. Crankshaft. Crankshaft is essentially the backbone of the internal combustion engine. The crankshaft is responsible for the proper operation of the engine and converting a linear motion to a rotational motion.
Operational principle of dual piston pump. A more efficient way to provide a constant and almost pulse-free flow is by using dual-headed reciprocating pumps. Both pump chambers are driven by the same motor through a common eccentric cam. This common drive also allows one piston to pump while the other is refilling. As a result, the two flow profiles overlap each other significantly, reducing the pulsation downstream of the pump. Think of pumping and refilling are like this. Amazing, right? Since the acceleration-deceleration profile is somewhat nonlinear, the more efficient types of those pumps use eccentricity-shaped cams to obtain the best overlapping of the pressure curve and to obtain smooth flow.
Application of dual piston pump. In oil, gas, petrochemical industry, used in processing in refineries. In mining industry, used as fire water pump at port and terminal, backfilling process, which is void in a mine after using overburden. In food industry, used in HPLC, is a method for separating organic and inorganic compound.
Now we will move on to the advantages and disadvantages for both piston pump, which is the reciprocating piston pump and also the dual piston pump. For reciprocating piston pump, some of the advantages are it has working pressures up to 5,000 bar, it has low noise level even at high vacuum state, and it is easy maintenance. On the other hand, the most familiar disadvantage for this pump is it has leakage between piston and cylinder, which reduces pump efficiency. For dual piston pump, the advantage is these pumps are the unlimited solver reservoir, allowing long-term unintended use and quick changeover and clean-out capability. For disadvantage, there is tendency for the incompletely compensated pulsations to be observable at high refractive index detector sensitivities.